All right, we are recording. Now, this is an interesting integral. It is an improper, so we have the integral from 0 to 28 of 1 divided by x minus 1 to the third power dx. This is also an improper integral. Why would that be? Why would this also be an improper integral? I mean here, let me just ask you this. Let me just ask you this real quick. Well, so I think this is probably helpful. Let me write our function down. The function is 1 over x minus 1 to the third power. Let's look at the endpoints. Is f of 0 defined? Yeah, and hold that thought, Javier. Javier, actually, f of 0 is defined. F of 0 is okay, and f of 28 is certainly okay. The problem is, Javier noted that the denominator here of this function is not defined at x equals 1. Right? Well, no, I'm not saying that right. The denominator, the function itself, the denominator of the function would equal 0 when x equals 1. And you can't have 1 divided by 0. So this function f of x would have an asymptote at x equals 1. And 1 is between 0 and 28. You see your bottom limit is 0. Good, Javier. And your top limit is 28. And 1, x equals 1, is between 0 and 28. And that's why this is an improper integral, because you have an asymptote in, right, that's right, Sandhya. And you can't have, I mean, well, if you were to graph this function, you would see there's an asymptote at x equals 1. Well, the x equals 1 is between the limits of 0 and 28. So that makes this integral improper. Okay, does that make sense, class? Give me a thumbs up if you're okay with that. Okay, very good, Jingson. Very good, Ange. All right. Well, the question is, what do we do? Very good, Sandhya. What do we do in this situation?
We split the integral into two terms.
Ange, that's very good. Your instincts are correct. We are going to split the integral into 2. And where's the split going to occur? At what value?
At 1.
At x equals 1. That's right. So, indeed, this is what we do. So for our solution, I'm going to take my integral, and I'm going to write it as the sum of 2 integrals. The first one goes from limits 0 to 1. The second integral goes from limits 1 to 28. And so I have 2 improper integrals that I need to find. Okay, so this first limit is of 1. I mean, I guess I have that, but let me write it a little more. Hold on, everybody. A 1, right? Okay, and so I get integrals 1 and 2. And now I have to evaluate each of them. They're both type 2 improper integrals. And if this integral from 0 to 28 is to converge, both of these integrals, I1 and I2, have to converge. So let's look at I1. So I1 is the integral from 0 to 1. And we know that the 1 is the problem. So I'm going to replace the 1 with a t. And I'm going to take the limit then of the integral from 0 to t as t approaches 1 from the left. From the left. Okay, let me get this. One moment here, class. Let me turn off my email. Good, okay. Yeah, so see, your, the interval here goes, well, let me, hold on. Do it like this. Okay, here's an interval from 0 to 28. And one's, this is not drawn to scale, but since your first integral goes from 0 to 1, how would you have to approach 1? You'd have to be approaching 1 from the left. And so that's why t approaches 1 from the left. And that's what that little negative sign up there means. How many recall that from their calculus days, the one-sided limits? Sure, Javier remembers them. And so, I'm going to let you, and Sandia does also. Good. We're going to do substitution here. Let u equals x minus 1, du equals dx. So my top limit becomes t minus 1, and my bottom limit becomes negative 1. So my new u limits are t minus 1 on top and negative 1 on the bottom. U is equal to x minus 1, and 0 minus 1 equals negative 1. So now this is just a simple integration problem, like you learned back in section 5.5. The only difference is one of your limits has a variable in it, the t minus 1, but the process is the same. U to the negative third, the antiderivative of u to the negative third is 3/2 times u to the positive 2/3. Right? So make that a little. Right? Please let me know if there are any questions so far. Mario says, how did I get negative 1? So here, notice that when the limit was with respect to x, the bottom limit was 0. But then we let u equals x minus 1. So that means then that, for the new u limit on the bottom, we got to take 0 and subtract 1. And that's how you get negative 1. Is that okay? Is that all right, Mario? Okay, good, good. Okay, so, all right, well, now we have to go to the next page.
Hey, Professor?
And evaluate this. Yes, D'Angelo.
Is that that's a 1/3, right, on the bottom?
No, it's a 2/3.
Okay.
Let me make it. All right, hold on. Good question. Yeah, this is a 2.
Thank you.
Over 3. What I can do, it's there, but let me just maybe do this. Hold on. Nothing wrong with this. 2 over 3. There you go. And then we have a 3/2 here. Are there any other good questions? All right, well, let's proceed on then. Let's proceed on to figure that what this limit is. So here I'm where I'm at. So the let me just write the other. Let me write something here. Hold on. So my I1 integral, from the previous page, as you recall, was the limit. Try this again. Nope. Okay, so this is what we had from the previous page. And you see, what I can do is I can take the 3/2, which is a constant, and I can pull that out in front of the limit. And that's how I got the 3/2 here. And then I'm going to substitute in t minus 1 in the antiderivative, and then I'm going to substitute -1 in the antiderivative. Okay? So if you, like from here, if you take the limit, I can put another step here. If you take the limit then, you'd have 2/3 times 1 minus 1 to the 2/3 power minus 1. But this here is 0, and that gets you here, and that gets you -3/2. So that first subintegral, that first improper integral converges, and it equals -3/2. So far, are we good? Okay, are there any questions before we go to the next page then? All right, if we're good, then does the 1 stay negative? Javier says, does the 1, can you circle the 1 that you mean, Javier? Can you circle the, oh, by the way, I have, this should be one moment here. I have a slight, it's no, hold on here, one moment. This was 3/2, right? Not 2/3. I just noticed that. Okay, you're good. Okay, all right. Yeah, all right. Well then, let's move to the next page. Now we have the second integral from 1 to 28. And if I draw myself, you know, an axis here from 1 to 28, I'm going to be approaching 1, have to be approaching it from the right. So therefore, I replace the 1 with the t, because the 1 is where the trouble is. And then we're going to approach t, we're going to let t approach 1 from the right. And so the process is similar, is the same as the first integral we did. We're going to let u equal x minus 1, du equals dx, and then you have to get, your new limits. Okay, so 28 minus 1 equals 27. And then, so let me know if you have any questions down to this step. I'll slow down a little bit so you can catch up. All right, so again, the process is the same. You get the same antiderivative for u to the negative 3/2. The antiderivative is 3/2 times u to the 2/3 power. Okay. Remember, how do you get u 3/2 times u to the 2/3 power? So you're looking for the antiderivative of u to the negative 1/3 right here, right? So you take u to the negative 1/3, add 1, and then below you have negative 1/3 plus 1. So that's going to be u to the 2/3 power. Let me leave myself more space here. I don't like to run out of space. So what I'm trying to do is talk about this antiderivative here, just a reminder. So you want the antiderivative of u to the negative 1/3. So of course what I have to do is I take u to the negative 1/3, I add 1, and then below I take negative 1/3 plus 1. So that equals u to the negative 2/3. U to the positive 2/3 over 2/3. But then that's just 3/2 times u to the 2/3. So that gets you there. And then you just keep going with it. So now we have to put in the 27. Okay, our limits of 27 and t minus 1, which I do here. The 3/2, I factored that out front. And if I put in an additional step here, when I take the limit, I'll get 3/2 times 9 minus 1 minus 1 to the 2/3 power. And so that will get me 3/2 times 9, and that gets me 27/2. So that second integral converged also. Are there any questions? All right. Well, what's then this our improper integral we wrote as the sum of two integrals. Okay. What would the and both those integrals converged. So what would the what would the final answer be for our improper integral for its value? What will we have to do with the two integrals? Okay, Jingsun, you're getting 12. How did you get 12? How did you get 12? That's correct. So how did you get 12? Good. You added the integrals. And that's what you do. So here we go. Right, you meant plus. That's right, Jingsun. You add the -3/2 and the 27/2, and that will get you 12. And this is how you have to do that kind of problem. Are there any questions? How many like these improper integrals? At least, I think they're interesting. Or who likes them? Okay, Javier likes them. That's good. And Ange does. Wonderful. Okay, I want to do one with you on the whiteboard. Okay, I'm going to actually do an example from the book here. I'm going to do it on the whiteboard, just so you have, I'm trying to give you variety here. Let me bring up the whiteboard. All right, so that integral converged. Another example. Okay, so let's say we wanted to evaluate the integral from 0 to 3 of 1/x minus 1. We want to evaluate that if possible. So why is this an improper integral? What's the problem here with this integral? That's right, Mario. When x equals 1, we have an asymptote for this function 1/x minus 1. There would be an asymptote there. And so that could be a problem, right? So what we have to do, right, is we have to take this integral, just like the last problem. We're going to take the integral, and we're going to split it up into two integrals, separated at 1. Okay. Are there any questions so far? All right. Well, what I'll do, let me focus on this first integral here. Let me focus on that. So, first integral, okay, we would write that as the integral from 0 to t. Okay, so I'm focused on the first integral now. Let me maybe separate this. Is this right, what I've written down here? Is this correct?
What's the limit when t go to?
Sorry, Ange?
I said the limit when t go to 1.
Ah, so I have to have a limit there. Good. Okay, the limit t would go to 1. From the left or the right? Good, Mario, from the left.
Yeah.
Okay. How would you solve this integral? What approach would you use? Would you use substitution, integration by parts? Use substitution, Mario says. All right, Mario, what would you let u be? X minus 1. Okay. So that means du equals dx. All right, and so we'll continue here. Just go down a little bit here. We'll have the limit as t approaches 1 from the left, 1 over u du. What's the top limit become? Or no, let's do the bottom. What's the bottom limit become? What's our new u limit going to be? The x limit was 0, but now we have a u limit.
Minus 1.
Minus 1. Good. And I appreciate all responses because 0 minus 1 equals -1. What about the top limit? What would the top limit be?
T minus 1.
T minus 1. Good. Okay, so now, of course, 1 over u is u to the -1st. Right, that's u to the -1st. So let me continue the problem. Maybe I'll just put in this step. Why not? Well, no, I'll put it over here. Even the whiteboard runs out, right? Sandia, you're right. What's the antiderivative of 1? Well, I could have left it like this. It probably would have been better to leave it this way. The antiderivative of 1 over u, as Sandia notes, is what? So I know Sandia knows it. What's the antiderivative of? So this here is really not necessary. This is what I did here. Okay. ln of good of absolute value of u where we have t from t minus 1 to negative 1. So now if I put my limits in, well, I'm not ready to do that yet. What I mean is I'm going to keep the limit there. And I'm going to have the natural log of the absolute value of t minus 1 minus the natural log of the absolute value of negative 1. Now the absolute value of 1 is 1. So I think, oh, I can go across here, can I? All right, let me go across here. So let me just write this a little bit more. So I have the limit as t approaches 1 from the left of the natural log of the absolute value of t minus 1 minus, okay, well, what's the log of 1 equal to, class? What's the natural log of 1 equal to? Yeah, that's 0. So this is what we have. Well, what does this equal here? So let's think about the log function. If we were to draw a little picture here. Hold on. Okay, this is y equals the natural log of x. Passes through x equals 1. So what does t minus 1 approach as t approaches 1 from the got to be a little bit careful here, from the left? What's t minus 1 go to? Well, all right, so as t approaches 1, that's right, nothing else. As t approaches 1, t minus 1 would go to what?
To 0.
This goes to 0. So when you take the limit, I guess what I'm asking is this. I don't want to write, too much that isn't necessary. But what I'm saying is, the fact that t minus 1 goes to 0, what's the log of 0 go to? guess I don't need this. I'm trying to discover, this isn't exactly necessary here. Nothing else. What did you say the answer was? What is this limit equal to?
Minus infinity.
That's exactly right. Well, that's the reason why, Sandy, is 0 is not in the domain. So as t minus 1 here, as t minus 1 approaches 0, it has to because t approaches 1. So t minus 1 approaches 0. That means then that this log of the absolute value of t minus 1 would approach the log of 0. Well, the log of 0, you can see it keeps going down to negative infinity.
Professor.
So let me ask, what this problem, the two integrals, we wanted to find, you know, we're working with the first integral here. What does the first integral do? Does it converge or diverge?
Professor, before we proceed, we're looking for t going 1 on the left side.
Correct.
So on the left side, there's no curves there. Like if you said, you know, if you do the graph and on the right side is go to minus and infinity, but
well, I didn't graph the log of t minus 1. I mean, I don't worry about that.
okay.
If don't worry about that at the moment. Now, t approaches 1, right? We're approaching 1.
Right.
So t approaches 1, and the log of t minus 1 would approach the log of 0, and that's negative infinity. Okay, so I'll finish this up quickly because we're so what I'm saying is, does this integral here, the integral from 0 to 1, does it converge or diverge? Based on the fact that, I mean, this equals negative infinity, right? This first integral. So does that mean converge or diverge?
Diverge.
Right. First integral diverges. Is it worth finding out anything about the second integral then? Or can we just say no? No. So the whole integral, we can say the whole, that's right, Javier, that's right, Mario. We can stop there. You know, like the last problem, because we had to find, you know, the first integral converged, so we had to see if the second integral converged. But here, since the first integral converged, we can say then that the entire integral, I'm sorry, in this problem, so in the last problem, since the first integral converged, we had to see if the second integral converged. But since here our first integral diverged, we don't need to go any further. We can say then that our whole integral here, our whole integral diverges. Okay, are there any questions on that? Does that make sense? Give me a thumbs up if you're okay with that. Give me a thumbs up. Okay, good. All right. Wonderful. So that's really you have some good examples now for section 5.10 to help you with your Tuesday's homework. Let me stop the recording.